Okay, so welcome back to the Golang implementation of the Boogie programming language. In this video, I'm not going to actually do much functionality when it comes to the language itself. I'm going to be implementing a built-in editor because that's something that I want for reasons that I might explain later as we go on in the video, because let's just get started. So if we look at our master branch here, there's a couple of things I want to start doing differently already. Reason being that I came up with some new architecture that I'd like to do. So maybe we can just delete this entire function here, and let's start a couple of things that we need to do. First of all, I want to be able to take in an edit file, or like a file to edit, which we will need if we are going to be making an editor. So we use the Go flags for that. And let's take the E flag, let's make test.boo our default file, and this will be the input file to edit. Alright, and then you need to call parse on flag, so it parses your flags. Then I also want to do take the OS arguments if I want to run my code instead of edit it first. So then let's skip some stuff for now and just start with some refactoring that we need to do from our master branch to bring it in line with the new architecture. So we have a new program struct. This is kind of like what we were doing in Python as well. So that means I will now need to make a program Go in the Boogie package. And program Go basically is kind of responsible for loading our program into memory. And in fact, it does something different, but we will see that soon. So I'm going to make a custom string type that is called line of code. And then I'm going to make a type called program, which is going to be a struct. Oops. And then I will need a file handler that is going to be of type OS file as a pointer. Great. Oops. Now, new program takes in a file path as a string and returns program as a pointer. File handler and error coming from OS open, takes in the file path, handle the error. For now we can just log fatal. We need to implement proper error handling like always, and return a pointer to program, file handler, initialize as fh. Okay, that sets up initialization. Why is that not happy? Undeclared name program. Oh. Learn to type. So this is going to have a generator function actually. So it's kind of interesting to see how to create a generator function in Go. It'll do generate lines and returns a channel that is a pointer to line of code, to that custom type. And that custom type really, it could have been just a string. I just like to do this so that down the pipeline of my code base, I still know what I'm talking about. It's descriptive more than anything. So it creates a channel, so make gen of pointer line of code, and then it also needs a scanner that is from the buff.io package. Just do new scanner, oops, program dot file handler. So that'll scan from the file handler that we created. Yeah. And then it'll start an anonymous Go routine. So it's basically an anonymous function, but started as a Go routine by putting a Go in front of it. Do not forget to take the file handler and close it. Defer statement makes it so that that statement is deferred to the end of the function. So all the code between this defer statement and the end of this anonymous function will run first before these two statements are run. Very useful to make sure that you remember to close handlers. So line of code is a line of code initialization that is scanner text. So scanner text will be a line read from the file that we are putting into this, and then sends that as a pointer over that out channel. So I'll go into a little bit more detail for this one, and then we'll write a few more generator functions down the line. So we can faithfully log here the error. Why do I keep pressing 0? There's something weird. And obviously this needs to be an invocation. So what is it not happy with? Happy? No. This needs to be a capital. Happy. Okay. So generator function in Go. Call it generate lines. It's just a method on this struct type that we created here, and it returns a channel of the type line of code as a pointer. So it creates that out channel, cast to the right type, then creates that scanner. That scanner just takes the file handler, which is the open file path over here, and reads it line by line. So then we create this anonymous Go routine. This is just a function. You can give it inputs as well here, like define the actual function footprint or whatever you call it, and then pass it in over here. So really just see it as a function, but it's anonymous, it has no name. And then with the Go statement in front of it, makes it into a Go routine, so it starts running concurrently. And that means that as soon as this Go func is called, it immediately returns the out. So it returns that channel back. Now, what keeps happening inside of this Go routine, because it keeps running while it's scanning, as long as it's scanning, this Go routine will keep running even though we've already returned the channel. So now this channel will be producing whatever is written to it over here. So that is how this is a generator. It's basically constantly generating content on this channel over type, and now we can read that somewhere and basically have that generate our lines for us line by line. This is useful for, because what I can do now is go back to my main.go. Now I have this program over here. All it does really is it creates a file handler at this point. It hasn't read any content yet, and that's something that we're going to look at now. So if we go back to our main, the next object we can set up is the lexer. So that will be the boogie.new lexer. Yeah. Only in this case now it takes in the program. So that will probably give me an error because it isn't used to that yet. Because at the moment it took in a channel, which is kind of like a standard architecture I always follow. However, I came up with this generator thing. I think it's a lot nicer. So now this takes the pointer to program. So it's just a memory address. Still returns a lexer. However, now this needs to become program. Don't forget the comma, and then here we need to define that we can actually take that in. So that's a pointer to program. Yeah. Oops. So I must have misspelled it somewhere again. Otherwise, it wouldn't be in the autocomplete program. Yes. we can actually now take this run function out completely and make another generator function. This is quite a nice architecture actually. It's just generator functions passed down the pipeline until we call evaluate, and that just sort of runs all the generators. So generate lexemes. By now, if you've seen some of the videos on this, or if you're interested in this at all, you probably start to recognize some of the terminology and kind of approaches we need to take to get to some form of a workable state. However, we are basically functioning on the editor. We just need to do a lot of refactoring. And it's probably not the wisest thing to do when it comes to the flow of how this is supposed to go. But I believe that, you know, if you're interested in Go and maybe not that profound in it yet or something, that there might be some nice learnings in here. And then whoever doesn't need this kind of stuff and can just look at the source code directly and just wants to get to the meat of it can just use the timestamps that are now a very nice feature of YouTube. However, I would need to stop being lazy and actually add them every time. So, same generator kind of function that we had in the previous one. In this case, we are preparing for parse lexemes, which we won't implement at this point in time, but just so we have some sketch of the architecture. And this is why I do that kind of thing, making a custom type. It just shows me right here where I have no access to that type directly. You know, I'm talking about a line of code here. Yeah, I could capture that in a variable here, line of code, just do it as a string. However, other people might not be familiar with LOC as a term, or LOC might mean something completely different in other domains. So return a lexeme. That's what we ultimately will want to return, which is something we haven't defined yet, so let's do that now. Let's make a lexeme.go, and a lexeme, yeah, kind of like you would expect it to be. Let's have a token type, make it an int. Then let's have an enum. So for now we'll just make the limiter the iota. That just means that will be initialized to 0, and we have those custom types again. And we'll have a token value that will be a string type. And then finally we'll have the lexeme type as a struct, which will have a token type, which will be of token type. And we'll have a token value, which will be of token value. So this is in preparation for being able to output lexemes. That basically means that we've now done whatever we need to do in the lexer, I believe. Yeah. Why is program generator lines not happy? This should be happy. Yeah. It always becomes more difficult to type. Let's see. Well, I'm gonna assume it's correct. So let's go back to our main and set up the parser. Which will take in the lexer. You can kind of now start to see maybe the pattern forming. Something is really not happy. Oh, just because I'm not using edit file. Okay, so what we'll do for now is just consume it into nothingness. That will make that happy. Parse is not used, and it doesn't like Lexer as an input, so that's all good then. That seems like we are all pretty good. So, ooh, this is not the parser you're looking for. It did not like that. Because I just don't have it yet. It just jumped to some random package. Let's create it. So what we'll need to do here is make a parser type. And it took a Lexer so that it can call its generator function. Func new parser. Note how at this point we haven't actually generated any data in this system yet, as in the file handler has been created, but no data has been read from it, no Lexer has been run, and even now when we will write the generator function for the parser, nothing is done yet. Like, this is all just sort of set up and it's passing itself through to itself, basically, to its individual components, until it's all set up and ready to go, which I kind of really like that. So here we'll build the AST, which will return the AST, which actually we haven't defined yet. So let's do that up here. Make an AST type. First, let's make an AST node that will be some form of a struct, and then make an AST type, which will also be a struct. For now we can leave those empty, but this will have something like, we can actually do that, like, it'll be something like that. And continuing on that, so var AST, and then for lexing is range parser dot lexer dot generate lexemes. Yeah. Do you ever have this like really weird form of like, it's like not quite deja vu and maybe not quite reverse deja vu, but where you see all of a sudden something and you know you did it, but you don't know if you did it correct, and you start to like doubt yourself, which it's still not happy indeed, but I did do my range correctly. So actually that's probably good to know. Remember how we talked about program, this was the example that we looked at, how it was producing on this channel here as being as of being a generator. So if we look at Lexer, which takes in the program, it does a for loop where it creates an allocation for a lock for a line of code by ranging over the Lexer program generate lines function. So basically, because this gives me back a channel, this generate lines, I can range over that channel. So while there's content being produced on that channel, I can basically loop over it. That's kind of what it is. This is really strange though, why it won't let me, we'll see if it actually throws an error. Sometimes the editor is just wrong. So we were at the parser level. I think that's all we really need to do. Return AST, yes. That's as far as we will set it up right now. Go back to the main function, do our final little bit here, or at least part of the final little bit, evaluator. So that will be evaluator dot, actually, that's why it's wrong. evaluator, new evaluator, and that will take the parser, I believe, yeah. Could actually probably just take the AST directly, but it's just pointers and it's fine for now. We don't actually have an evaluator yet. So let's write it. It shouldn't be a lot, and it's not. So, actually, didn't I have like a nice little... Yeah, that worked out pretty well. I'm starting to set up snippets because I'm just typing the same thing over and over again now in my life, and it's not going great. So that took the parser actually. Oops, yeah. That took the parser. Let's remove that. Let's actually take in the parser. Definitely need to do that. And then make a little function here, which is generate output. And again, it has a channel of strings. So again, this will be a generator. Every time I type generate in front of a function, it's most likely a generator. So we'll create a new channel for that. Go func. Defer the closing of the out channel. So it's done once we're done writing to it. Yeah, create a test string for now. And write to out that string as a pointer. Invoke the function. That's always a bit of a weird syntax, but it makes sense if you think about it. That if you make one of these anonymous functions that you want to run, that you actually have to invoke it to run it. That's quite important. So that's evaluator. Back to main. Now all we have to do is to run the entire process of our programming language and stuff. Is range over the evaluator output channel. Generate output, which will just print actually the reference of the output. So why that works like that is if I go in there, generate output reads from should be reading from the parser channel, yeah. So the parser, like it reads from generate lexemes. So it has its build AST method, and that reads from generate lexemes, right? Generate lexemes reads from program generate lines, and generate lines reads from a file. So all of these are only run until you call the final sort of generator function, which is in our case here. However, I'm not actually calling parser build AST yet. So that would be the way to actually make that work. You'd have to do something like yeah, you'd have to build the AST over here and then finally run over you have to call build AST over here, because I don't think the parser does that. It has the method for it, and that's when it starts actually doing its thing. So this also still needs methods to actually convert the tokens and stuff. But again, after all that, this was not what it was about. We were going to make a built-in editor. So what we can do is most likely run this. I think that should probably work, and at least we'll get to see the errors if we have any, which, you know, of course we will do. This actually is okay. There is a bug in there, but that's really not that important for now. What we can do is just start building our editor, because it'll be fun. So to do that, we actually want to take this if edit file is not nil. The reason, by the way, sorry, it's probably good to show, otherwise maybe it's just confusing. The reason that this doesn't work is because these things are conflicting. So the way that a program takes in its program is different from the way that edit file is set up. So in any case, nope. So if we actually are passing the file name correctly, then we're going to make a new package, and it's going to be called apeterm. It's going to have a new UI method. So let's start implementing that, and then it will make sense. So go here, create a new directory called apeterm, or whatever you want to call it, obviously, and create a file in there called UI. So UI is going to do a couple of things. First of all, it's going to delete all that, creates a new package called apeterm. What you want to do is create a type called UI struct, and it will have a writer, which is an IO writer. It will have a reader, which is an IO reader, and it will that'll be it actually. So then it will have a new UI, returns the UI, and return UI writer. Oops. It's gonna read. It's gonna write to standard out of your terminal, and it's gonna be reading from standard in your terminal. This will allow us to basically take input from the TTY, from the terminal, and convert it to a stream of bytes, which we will in turn convert to strings. So that will basically allow us to not just take lines of input that you have to press enter for, so lines of input. I want to have character by character input, because I want to, in my internal editor, since I'm used to Vim, I want to do some work on emulating Vim in my built-in editor. However, I'm going to make some changes to it, because there are things with Vim I'm not super happy about. So I'm going to try to make some changes to it and maybe make it work a little bit more like I want, because that's the fun of building everything from scratch. So what we will do now, create a method on UI called read input byte. And I should probably rename that as string. But it's really not like kind of the go away, right? Like, I don't know. We'll see about naming later. Again, the philosophy is don't stress about it and just write something that works. That's at least the philosophy on this side of the keyboard. So create an infinite for loop. Start reading. No, create a 1 byte, and then ignore whatever is coming back from the byte count. Then take your reader, cast it to a pointer of OS file, and this needs to be removed out of this loop because it's ridiculous, but and completely unnecessary. I could do it right now, but I'm definitely that lazy, and I also don't want to break my flow. So if the error is not IO end of file, we return an empty string and the error. Okay, so let's quickly break that down and see where I messed up. because I always mess up. Reader cast it to OS file, call read, and actually, you know, reference the variable that you're talking about. RBuff is just not beerware. Alright. Right, so now if buffer 0, we actually probably don't have to do that check right now. Let's not do that. So now RBuff is append to RBuff, the value will be buff 0. Then if the length of RBuff bigger than 0, what you can do then is just return the string version of RBuff. And that's why I said that I should probably rename this method or remove the string casting out of this method, because it's called read input byte, but it returns a string. So string RBuff nil. Why is that not happy? Unreachable code. Right. Interesting. I don't think it will. It's just a warning. Yeah. In fact, what I could do instead of this, I can actually just break. That makes much more sense. And then I could probably do the same thing over here, because error will be nil. So I can just return error. What's with the beerware? It's a new code completion plugin, not completely used to it yet. So yeah, then we can just break over here as well, and that should just bubble back pretty nicely. However, then we do need to actually make error first, and that means that we can no longer assign it here. We have to yeah, assign it but not allocate it. Okay, that's all good. So we have our read input byte method. The way that that's going to be used is going to make it make more sense, basically. Go back to our main method. Now we have a UI. What we want to do now is create a buffer, and that's kind of like Vim, you know. I'm gonna call my editor Eddie. It's gonna create me a new buffer, passing in the UI and edit file. So I'm hoping that that's starting to make sense. That's just going to be a buffer that we can work with. Okay, create a new directory, call it Eddie. It's basically a new package we're creating. And then create a new file called buffer.go. Open it up, delete the template, go to package Eddie, and create a type called buffer. Why am I doing this? I had my little method, buffer, happy. Okay, let's write buffer real quick. Buffer actually needs to do quite a bit of work, so maybe it's not that quick as we think. It takes in the UI, so and actually that's from the ape-term package. So if you aren't familiar, now you can kind of see how you reference stuff from other packages. Just type the package name, and if you have your Go binaries installed, all of the tooling, then the import will actually be automatic on save. So if we look now, when I save, it automatically created this import for me, so I don't have to worry about that too much. So let's assign UI and actually take it in. So that's an ape-term UI, and actually that's a comma. The file path is file path, we still need to take that in, and then also we want to convert the data, so we make a string array or slice that will automatically grow. If we pass in 0, it will automatically grow as we need. and that's a pointer to string up. Alrighty, so the next thing is we want to create a load method to actually load our file content. So load, what does it do? It creates a file handler and an error. We use OS open buffer.file path. And as you can see now, if you look at the top of the file where the import is done, when I save, it automatically rewrote that import statement now to take OS as well. Let's handle the error. If the error is not nil, let's just fatally log the error. And then we need a new scanner, kind of what we did before. Buffio, new scanner, file handler for scanner.scan, buffer.data equals, append buffer.data scanner.text. So again, what that does is it creates a scanner for that file that we opening, for the file handler we've opened, and it will read line by line, adding those lines to buffer.data. And then what we can do is, well, we can just print that. Or actually, let's print it as a line. Buffer.get data. We'll make a getter method. Let's do that now. So that will be on buffer. Get data. Doesn't take anything. Returns everything as a string. All that does is basically converts the array into a joined string. So it will do buffer.data. And I don't think it actually needs to join on /n, because I think the /n will already come from the scanner, from the file itself. So for now, we won't do anything with that. Now it's not happy with this because it's probably lowercase f, so that seems all good. Okay, we aren't quite done here yet. We need a couple more methods, and it makes sense to write them now. However, they probably will make more sense in a little bit. So we need to actually be able to set focus to a buffer, because if we have multiple buffers open, we need to be able to switch between them if we want to do that. So for now, what it will do, set focus, is it actually will handle our raw setting of the terminal. If error is not nil, we can actually panic in this case and defer terminal dot restore 0 dot old state. So what this does is terminals, they have multiple modes that they can work in. Some of them, they are basically mostly for a read line method. So what that will do is, like, it will allow you to type, and then none of that is actually I think none of that is interpreted directly, and then when you hit enter it is interpreted. However, there is also a raw mode, and that allows you to do things like what Vim does, where you actually get to write directly to the screen buffer and have much more control over how you want to write certain certain fields or cells on the screen, which will allow you to do really cool things like basically like drawing on the screen. However, you need to draw with nothing but ASCII characters, well, ANSI characters to be honest. And then, you know, using ANSI escape codes, which we will do later, it will allow you to also do a lot with colors and stuff. So restore to old state, because you do need to keep track of the old state, otherwise you will fuck up your terminal once you exit your program, because it will still be in raw mode, which won't be good for your emulator to work with. So buffer.ui read input byte is what we called it, yeah. And then to be able to actually exit, we can just type Q. That will break the loop. And otherwise, what we will do for now is just print the string. Let's get that out of the way. So what this should be doing is, okay, make the terminal, set the terminal to raw mode, so we can actually do more interesting things with it, which we will see in a later video. Make sure that we will defer at the end of the function when we've broken out of the for loop, so here, restoring the terminal back to its old state, so when we exit the program we actually can use our terminal again. And then just start reading input bytes from that method that we created earlier here in real time into a string, and then just print that string, or if we type Q then break. So we can actually almost test it, we're not done yet. Let's go back to main real quick. In main we still need to actually make the implementation of buffer. So we said we had a load method that will load the file content into data. Then we had a set focus method, and then later on, like, we can already set this up. We can override prog to get data, and that will allow us to actually load whatever we type there into the rest, into the program, the lex or whatever. So now all we need to do is go there and run it, and what it should be happening now is it should actually have stopped. It took input for some reason. That's kind of strange. What are we doing wrong? Let's make sure that buffer is correct, because that one will actually break. String Q read input byte. That seems all good. Do I actually have that file, test.bool? Ah, okay, so I don't even have it. That's weird. The reason being, okay, I know why. So here we can just say, like, okay, a equals 1, b equals a plus 1. I don't know. Write some code basically. And then actually we need to do -e, because that's the flag that we set if we wanted to edit something. So now when we run it, it loads in our previous line, and when we start typing, we actually can type. We now have an enter. We cannot use enter. It will go back to the first line. The reason is that your terminal is now in raw mode, so you will have to handle all of that cursor positioning yourself. So when you press enter, you need to actually switch to the next row down. But that's something that we will do in a later video coming up pretty soon, because yeah, this has probably already gone on pretty long. But yeah, so basically, to explain it maybe a little bit at the end, I'm now working on basically 2 implementations of the Boogie language, one in Python, one in Go. I think the Python one is basically the prototyping version, and this will be the actual implementation of what I want to be creating. I'm going to now hit Q, and that will exit me, and I'm back in my normal, I think it's called cooked mode of the terminal. So that's pretty important.